Hey, what's up, everybody? Putting together a deep dive video on different solidity challenges. Starting out with this one here from Calyptus. They're putting out their challenge number 530. The idea of this video is I'm going to go through and walk through the concepts of the contract itself and then provide an overview of how you come to the solution. So, looking at this one real quick, you can see it on the screen what exactly the base contract is that they're looking at. And on the right hand side, you can see that they're proposing a specific question. So, looking at the contract, the token contract, swap contract, were there any potential issues? Off the bat, you can look at this, and there's a couple that are artificial issues here. First and foremost, the contract itself doesn't have the required license information, the pragma statements that are part of the contracts. That being aside, because it's not necessarily the intent of the questions, we're going to look at this piece by piece and figure out what exactly is going on and then demonstrate it with some actual code. So what is this contract doing? Essentially, you have two different tokens, token one and token two, that are using a interface to represent an ERC20 token. In this case, it doesn't necessarily spell it out, but based off of the popularity, we can assume that they're using one of the interfaces from OpenZeppelin, which is one of the most commonly used implementations for ERC20, ERC721, 1155s, many of the different standards for Ethereum networks or EVM networks, I should say. We have two tokens, and then we have a rate, which is being used. So every X amount of token two, you get, for every one of token one, you get X amount of token two based off of that rate. So the constructor is pretty straightforward. We take the addresses of the two tokens and then the rate, and we just store them in the variables that we declared in the contract. And then there's two built-in functions. There's a swap function, which takes an amount. Both of these are external, meaning you can call them from outside the contract. And then there's two require statements in this first function. So this first require statement is essentially saying that token one, which we've instantiated as an ERC20 token, is going to call its transfer from method, which again is built as part of that interface we're assuming with OpenZeppelin. It's going to transfer from the sender, whoever is calling the swap, and it's going to send it to this contract address. And they're going to send the amount that's being specified. So if you put an amount of 10, it's going to take 10 of token one, pass it to this contract, and remove it from message.sender's balance. Then we calculate the swap amount. So the swap amount is going to be equal to the amount that's passed times the rate, which was hard coded with the contract creation. And then we do another require statement. So there we take the second token, and then assuming that there is a value of that token inside the contract, this is one of the issues here. Assuming there is a value of that token already within this contract, then it will transfer it to the person who called the function, the message.sender, in the amount that it's supposed to, that swap amount. If for some reason something fails there, everything gets reverted because we've wrapped it all in require statements. So everything needs to succeed, otherwise the entire transaction fails. Second function down here is just a withdrawal function, which takes the address for whatever token you want to withdraw and how much of it. Again, it's being called from an external entity outside the contract, and it just creates a ERC20 instance of that token address and transfers it from this contract to the message.sender in that amount. So this is actually the second area that's an issue as well. And that's the primary issue as well that we're going to discuss here. So to dive into this, I actually have Remix pulled up and a basic implementation of the contract. There's a few minor changes in this case. One, I've added the pragma statement, the license information I was missing, just so that it would compile. And in addition to that, I've grabbed the OpenZeppelin implementation of IERC20, and then just added that as an additional file. So I just grabbed it off of GitHub and named it IERC20. And then I'm making a reference to import that as part of this contract. Other than that, we have the same contract definition. We have the same constructor. We have the same swap function and the same withdrawal function, exactly as it was on the challenge. I've already gone through and did some preparation work. I've also created a token contract, a basic token contract that just imports IERC20 and creates an instance of it. And I used that to create two different tokens when I deployed it. If you want me to go more in depth and discuss how you actually create these tokens and how you deploy them, leave a comment below and I'll gladly put another video together for that. But for the purpose of saving time, I've gone ahead and deployed two contracts already. A standard token, basically using that token contract, and created one which had a name here. I think I just called it token one and had a value of, I think, 10,000. I can actually go here and look at the method itself. Total supply is 10,000. I created it with 0 decimal places just for simplicity in this case, so I don't have to worry about fractions or fractions of a ERC20 token. And then other than that, it's set up so that once it is deployed, it basically mints all of the tokens to the deployer, the person who deploys a contract. I did the same thing with the second token. In this case, I made the total supply 20,000. And then everything else is essentially the same other than the name. This one is called token 2 instead of token 1. And then after I deployed those two contracts, I took a couple of the built-in accounts, just using the VM, and distributed some tokens to them. That's where you can see down here the different addresses, so we can check the balance of, for token 1, we can check balance here of the person who deployed it, and they've sent 100 tokens away so far. We can check the balance of the second address here, and they have 100 of them. We have this third address, and they have none. We can do the same thing for the second token we created. And then we can see how much was sent to the other addresses. Okay, so each of those had 200. And then I copied down the contract address for token 1, contract address for token 2. And then when I deployed the swap contract, I copied that one as well. So deploying the swap contract, all I had to do there was put in the address for token 1, address for token 2, and the rate. And in this case, I did a rate of 2 to 1. Now, a couple things here, if we try to call the swap token, so let me switch to an account that has this account 2 here, has some of token 1. And if we try to call the method right away, we call the swap method, and we say they want to send 10, we're going to get an error here. So why are we getting an error? There's a couple of reasons to this. One is because there's a couple instances. One, where if we look at the swap, first thing it does is a require statement, and it checks if we're trying to transfer from the message.sender. So one of the reasons we're not able to transfer that is because we never did an approve function. So we need to go to token 1. And I'll grab the address of this user. So we have token 1, and we have to approve. And with the approve function, we'd have to say who the spender is. So in this case, the spender is going to be the swap contract. And then we can say how much we want them to do. We can say up to, in this case, we'll assume that we're just want to send 10. So we put in 10. And what this allows it to do is when we call this function, the swap function, it will give permission for that contract, the swap contract, to take 10 of the tokens out of account one's balance and move it to the contract's balance. So now that we've approved that, we can try it again. If we do this, we're going to see another failure. So why is it failing another time? It's primarily because as part of the swap function, we're getting past this first require statement. We're getting through this swap, but there is no value of token 2 that's currently present to send back. So it's going to fail there. So right now the contract is operating as expected. So how do we change that? We can manually send some of the tokens from our root account that has a whole bunch of them. And we can start filling it in. So go to transfer. We're going to transfer to the contractor swap, and let's throw 500 in there. Okay. Actually, that's token 1. So we want to do this with token 2. So now there's at least some starting balance inside the contract for it to execute the swap. Now we will try this again. And this time it should succeed. Let's see what happened here. So total balance. Oh, that's because I am still on my root account and we wanted to do the swap from this one. This is the one that sent the approval for the 10. So now let's do it again. And we see that it succeeded. So now if we check the balances again for this account number 2, so if we look at the balance of token 1, we should see that their balance went down by 10. So they went from 100 to 90. And they should have a balance here that has gone up by 20, which is twice the amount. So everything is working. So for all intents and purposes, the swap function is working as expected. Now the real problem comes in with the withdraw. And to demonstrate that, I'm going to use one of these other accounts here. I'll just use account 3 to demonstrate. Actually, before I do that, let me check the balances of each of these tokens for the swap contract. So the swap contract for token 1 now has 10 tokens. For token 2, remember we built it with 500 initially, so it should have 480, which is correct. Now, with the withdrawal function, the primary issue of this contract is that there is no security mechanisms in place to verify that somebody could only withdraw an amount that they're authorized to. Essentially, this is open up so that any user can call this function and take out any amount that they want for either of the contracts. The way you would try to fix this is you would have, theoretically in this case, you would want only the owner of the contract to be able to perform this action, unless for some reason you have a reason why other people would want to withdraw from the balance of the contract itself. But in that case, you can still do the same thing. You can have a mapping put in place of authorized people to take it out, and maybe you have split profits, and then for every token that gets put in, it gets split 5 ways between 5 different addresses. But that's beyond the scope of this. To demonstrate why this is a problem here, I'm going to switch over here to account number 3, which has not sent anything yet. If we look at this account's balances of the tokens, they currently have 0 for token 1, and they have 200 for token 2. But this one is going to call the withdrawal function And they're going to first withdraw token 1 by passing in the address, and we'll say they want to take all 10 out of there. And that succeeded. If we look at the balance now of the swap contract for token 1, now it says 0. If we look at the balance of this here, we just took the 10. We can do the same thing for the second token and even drain all of that. In this case, we don't have to necessarily do all of it. We had 480 in there. Let's say we just want to take 400. And now if we look at the balance of this address again for token 2, which started off with 200, they now have 600, and the balance of the contract itself should be 80. So again, how would you fix something? Again, once this is deployed, the downside of EVM compatible networks using something like Solidity here is once it's deployed, it's stuck like this. But to get around this, when you are deploying it again, the first time, you would do something like address owner. And then in the constructor, set the owner to message.sender. So whoever deploys the contract is the owner. Then down here with the withdrawal function, you can easily do this with another require statement saying that message.sender, whoever is calling the withdrawal function, has to be equal to owner. If not, put a message you're not the owner. And then that would fix essentially all of the issues here within this contract. Again, I hope you liked this content. If you thought it was helpful, click the like button, hit the subscribe. I'm going to try to be doing this for all the different challenges that come out going forward. I post the responses, or I'm at least trying to post responses there on my Twitter account, which is the Pixel Plants SGB. That's part of my projects on the Flare and Songbird networks. So look forward to more videos for this coming forward.